We're starting 4.2 today. 4.2 is about greatest common factor, which what you'll hear from now on, I will always refer to it as something called the GCF, and once again, that just stands for the greatest common factor. The definition of a GCF, or the greatest common factor, simply means the largest common factor of two or more numbers. So when you think about that word common right there, you're just thinking about things that people have in common, okay? Right now I can look at Alex and Landon and see they're both wearing blue. That's in common, okay? I can see Michael and Kyla are both wearing khaki pants. They have something in common. So when we're talking about a GCF, you are looking for the largest common factor. That means a number that they have in common or that they share of two or more numbers. For number one, you're going to find some problems that look like this in your homework tonight. And the instructions are going to tell you find the greatest common factor, or find the GCF, of the numbers by listing factors. Notice right here, this says listing factors. There's going to be two separate ways tonight in your homework that it asks you to do something, but the first way is going to be by listing the factors. Now this right here, I put a tip in there that you're going to write in a red pen. This is not practical for large numbers. So if you have a really big number like 300 or 650, you're not going to use this kind of a method for something like that because it would take too long. But here's what you're going to do. First off, you're going to list the factors and then you will circle the pairs. So we're looking at number 21 first. Yesterday we started doing this. What two numbers can you multiply by each other to get 21? 1 times what number? 1 times 21 equals 21. So we're going to go ahead and list these different facts down here, what the factors are that would give us a 21. Can a 2 go into a 21? No. No, why not?
Because it's not an even number.
It's not an even number. Can a 3 go into it?
Yes.
Yes. If you remember, I taught you yesterday, you add these two numbers. 2 plus 1 would equal 3, okay? A 3 can fit into a 3. That means a 3 can fit into a 21. How many times can 3 go into 21? 7. Now I want you to see, are there any other numbers that you can multiply together and get a 21? What do you think? What is the next two numbers that multiply together to get 21?
7 times 3.
7 times 3, all right? And do I already have one that looks like 7 times 3?
Yes.
Yes, so I'm not going to rewrite it. Therefore, that's it. There's only two different facts right there that are going to equal a 21. Let's move on to the number 42. What's the very first one, Asia, that's going to equal a 42?
1 times 42.
1 times 42 is correct. Landon, what would the next one be? All right, a 2 can go into it. We could tell that because this is an even number. 2 times what number equals 42?
21.
If you don't know it off the top of your head, Landon, go and stick it into your calculator and plug in 42 divided by the number 2. What do you get? 21 is correct. Okay, let's go on to the next one. Kyla, what do you think? What else goes into a 42?
6.
Okay, there's something smaller than 6. Let's think about it. If I add 4 plus 2, I get 6. Can a 3 go into a 6? Yes, so that means a 3 can go into a 42. How many times can 3 go into 42? 14 is correct. All right, I want you guys to play around with your calculators. Push different buttons in there to divide and see what the next number would be. Once you think you know what it is, go ahead and stand beside your chair. All right, help me out, class. What comes next?
6 times 7.
6 times 7, all right? Are there any more? No. As you can see, we came over here. The next one would be 7 times 6, but we don't need to do that because we've already got it right there, okay? So these are our final numbers for 21 and 42. You guys can go ahead and have a seat. Okay, so here you can see what we said. First thing we're going to do is we've got to list the factors, okay? So right here, I want to list my factors. We started talking about that from yesterday. You're going to go ahead and list them right underneath here, 21. What are the 4 numbers that have to do with a factor of 21, guys?
1, 3, 7, and 21.
1, 3, 7, and 21. Excellent. Now we've got to list the factors for 42. So go ahead and write those down for me. Okay, so we know the first thing it told us to do was to list the factors. What is the second part it tells us to do now? It says then circle the pairs. So I want you to pull out your red pen. Tonight on your homework, you're not going to use a red pen, but I do want you to use it today just to kind of help us have these pop out a little bit more. When I'm looking at a pair, do you see any pairs that a 21 has that the 42 also has? What's the first number they share?
1.
The 1. So go ahead and circle that. The 21 has a 1 and the 42 has a 1. Are there any other numbers that they both share? Katie, what's the next one? A 3. They both have a 3 in them. So let's go ahead and circle those pairs. Anything else? Shikari? 7. So let's circle 7 and 7. Are there any other numbers that they share? Gabby? 21. All right. Now those ones are kind of far away. You can circle 21 and 21 like that if you want, or you can connect it. Okay. Now here's what my instructions have asked us. If I go back to reread my instructions, it says find the greatest common factor. Remember, something in common is something that they share, and you want the biggest one. What was the biggest number that these guys shared? 21. So you're going to write it down here. I kind of ran out of room at the bottom, so I'm going to just try to squeeze it in. But the GCF is how you're going to write it. You don't have to write out all the words greatest common factor. The GCF equals 21 because the greatest number that they had in common was a 21. And that is how you find the GCF by, as you can see, I've highlighted, listing factors because you listed all the different factors. All right, we're going to do one more example like this, and in a little bit I'm going to show you how to do it a different way. So the difference we have with problem B now is that there are 3 numbers. We're still going to have the same exact instructions. We're finding the GCF, or the greatest common factor, but now we're trying to find the greatest common factor that all 3 of these guys have. So Asia, help me out with the first one, number 14. What are my factors that go into a 14? Good job. What else?
2 times 7.
Okay, what else?
That's it.
That is it. Very good job. Let's go to the next one. Who wants to do 35 for me? Landon. First one.
1 times 35.
Excellent.
5 times 7.
Okay, anything else?
No.
You are correct, okay? As you do this, you can plug it into your calculator, okay? 35 divided by 6. If you did 35 divided by 6, you would see, nope, it doesn't come out as a whole number. If I did 35 divided by 4, you'd find the same exact thing, okay? So if you don't know these off the top of your head, just start plugging them into your calculator, okay? Let's go to the next one, 63. Who can do that one for me? Jakari, first one.
1 times 63.
Excellent. What's another one?
3 times 21.
3 times 21, and there's one more.
8 times 9.
Not 8 times 9. 8 times 9 is 72.
Oh, 6 times 6.
Very good. 7 times 9, okay? So now, looking up there, the first step, it tells me to list all the factors. So I'm going to start with the number 14. My factors for the number 14 are 1, 2, 7, and 14. Then you just go to the next one. You're going to stick it directly underneath it, number 35. I've got 1, 5, 7, and 35. Now the only difference between this and the last one is now I've got a third number, so I'm going on to number 63. Now remember, all you're doing is you are going ahead, seeing those first ones right there. I'm writing it down 1, 3, and 7. Now you're just going right back up. Remember, you want these to be in order from least to greatest. Then I've got 9, 21, and 63. After it tells us step 1 is to list all the factors, what's the next part I have to do, guys? Circle the pairs, okay? So now this is a little trickier. I've got 3 numbers here, so I've got to find something that all 3 of them have in common. What's the first number, Jakari, that they all have in common? A 1. So I'm going to use, just for now, use your red pen, but remember on your homework tonight, please just use a pencil, okay? Next up, Carlos, what's the next number that all 3 numbers share? A 7. And Emma, what's the next number that all 3 numbers share? There are no more, okay? So now I am finding the GCF. Tell me again, guys, what does GCF stand for?
Greatest common factor.
Greatest common factor. So remember, key word here, greatest. What is the greatest number that they have in common? 7. So your GCF is 7. Any questions? All right, number 2, we're going to take it just a little step further. This is talking about how to identify if something is relatively prime or if it's not relatively prime. Okay, this is a new term for us. Do you guys remember yesterday how we talked about prime numbers? What makes something a prime number?
If there's no numbers that can multiply but 1 times the number itself.
Okay, if it only can have factors that are 1 in itself. So relatively prime, as you can see here in red, it says if there are no pairs between the two numbers, the GCF will be 1, and they are called relatively prime. So if there's no other pairs between them except for the number 1, they will always be relatively prime, okay? So we'll talk about what that means here with the numbers 65 and 112. All right, let's look at the first one, 65. Who can help me out? What's the first factors of 65? Katie?
1 times 65.
1 times 65 is correct. I want you guys to think about what you think the next one would be. All right, we're still doing the same exact thing, but we're trying to decide if these are relatively prime or not. Jakari?
5 times.
It is 5 times something. Use that calculator. And all you do is the opposite of multiply is to divide. So you would simply go 65 divided by 5, and that would give you your number. What do you get?
13.
5 times 13, okay? What other numbers can be multiplied together and equal a 65?
3 times 15.
3 times 15. If you actually put 3 times 15 in your calculator, double check to see what you would get. It would not be 65. 3 times 15 would be 45, okay? So that's not 1. What do you think?
There is no other.
There are no other factors that fit into 65, okay? So now we're ready to move on to 112. I want you guys to take a couple minutes and try to do this on your own and see if you can figure out all the factors that fit into it, okay? Take a couple minutes. All right, let's see what we come up with. What's the first one?
1 times 100.
1 times 112. What's the next one?
2 times 56.
2 times 56. Next.
4 times 28.
Good job, guys. 4 times 28. What else?
7 times 16.
Very good. Anything else?
8 times 14.
All right, any more?
No.
Very good job. Okay, so we're going to keep doing it exactly like we did it before. The first step, I have to list the
Numbers.
factors. Okay, remember factors fit into numbers, so these are all the numbers that fit into it evenly. So for a 65, I know I had a 1, 5, 13, and 65. Now let's go ahead and list the numbers for 112. We know that we had 1, 2, 4, 7, 8, 14, 16, 28, 56, and 112. So the first step that it told us to do was to list the factors. What's the second step we have to do now?
Take the pairs.
Circle the pairs. Help me out, Alex. What's the very first number that you see that they both share and they both have in common? You are correct. They both have the number 1 in common, so go ahead and circle it. What's the next number that they both have in common? Katie?
There's no other numbers.
There are no other numbers, okay? So I can sit here and I can look at my 5 first of all and see there's no other 5s, all right? So that one's not true. I can look at the 13. Down here, there are no number 13s, so that's not true. Last one is 65. As I look over here, once again, no other 65s. Therefore, that means my GCF is what, guys?
1.
It is 1. Now, here's the extra tip that I want you to put in. Read me again what it says in red at the top of our slide. If there are no pairs, the GCF is 1, and they are relatively prime. So I want you just to write right there as part of your answer, relatively prime. Tonight on your homework, it's going to ask you to say, is this relatively prime or is this not relatively prime? Because the GCF is 1, that just means your answer is called relatively prime. That's because only the number 1 is what they share in common and no other numbers do they have in common. So tonight, just be looking carefully to see if it asks you to tell whether it's relatively prime or not. I want you to go ahead and skip a line and write this down for me, number 3. Number 3 is asking us to find the GCF, or to find the greatest common factor of the numbers using prime factorization. I want you to go ahead and underline that part with your red pen. Here's the difference. The last one, I was asking you to find the GCF by listing factors. For this one, instead, you're doing it totally different. You're doing it prime factorization. Do you guys remember what prime factorization is?
What's the definition?
upside down division, okay? So anytime you see the words prime factorization, that simply means upside down division. Then you're going to tell whether or not the numbers are relatively prime. So there's some steps we're going to be going through. Number one, prime factorization. As you see right there, you wrote it in red. That just means upside down division. Second, what do you guys need to do? Okay, thank you, all one of you, for reading it to us. You list the prime factors from least to greatest. Just the boys. Read me, what do you do for number 3?
Circle the pairs.
Circle the pairs. Good job. Girls, number 4.
For each pair, write the number 1 time.
And lastly, everybody tell me what our 5th step is.
Multiply those numbers together, get the GCF.
All right, these are a lot of steps to remember of what to do when you're trying to do prime factorization, okay? So as you're doing your homework tonight, use these notes to help you if you see the instructions say here to find the GCF using prime factorization. So those instructions I just gave to you, we are going to be finding the GCF using prime factorization. Tell me one more time, guys, what does prime factorization mean? Upside down division, okay? So what is the tiniest prime number that can fit into 84?
1.
Not 1. Remember, 1 is not prime or composite. 2, okay? So let's do that upside down division sign, divided by 2. What is 84 divided by 2? 42. Okay, Carlos, what's the next tiniest prime number that can go into a 42? I want the tiniest prime number. 2. So we're going to divide by 2 again. Carlos, what is 42 divided by 2? 21. Okay, Emma, what's the next tiniest prime number that can go into a 21? A 3 is correct. So what's 21 divided by 3? 7 is correct. What's the tiniest prime number that fits into a 7?
Nothing.
Nothing else. So here's how you actually know that you're finished, because the 7 is a prime number. So that means we're finished, okay? Let's go on to the number 216. What is the tiniest prime number that goes into 216? 2. So we're going to divide it by 2. Michael, what do you get? 108. Asia, what's the next one? What should I do? 108 divided by 2, and what do you get? 54. Who can help me out with what to do next? Landon, what do I do? Okay, so I want to divide it by 2. What do I get? All right, very good. 27. Is 27 a prime number?
No.
No, it's not. So I need to keep going. What number can go into 27, Gabby?
3.
A 3. What is 27 divided by 3? 9. Is number 9 a prime number? No, it's not, because there are numbers that can still fit into it other than 1 and 9. What number goes into that? 3. What's 9 divided by 3? 3. Is that a prime number?
Yes.
Yes. Now's when we're going to look at our steps that we just wrote down from our last slide. So the first thing you do is prime factorization, which you guys just did. Next up, you're going to list the prime factors from least to greatest, okay? So here we've got a 2, then a 2, then a 3, then a 7. Okay, remember, you're listing only the numbers that are out here on the outside. Let's go to the next one. 216, I've got 2, another 2, another 2, a 3, and another 3. Sorry about that. Okay, so these are all the numbers that we have listed of the prime factors. Now we have to circle the pairs. Kyla, what's the first pair you see there? 2. Think about when someone gets married. The 2 become 1, okay? So we're going to be doing that here in just a minute. What other factors do you see that they share, guys?
2.
Another 2, okay? What's another one?
3.
3. Now here's one thing I want to point out to you. This is a 3 and a 3, but they both come from the number 216. We're trying to find pairs from the 84 and from the 216, okay? Now, after we've circled the pair, it says for each pair, write the number 1 time. So you're going to go ahead, the 2's become a 2, and you're going to multiply it by that 2 becomes another 2. And then those numbers become a 3, okay? Now the final step tells us to multiply those together. When we multiply those together, we get 12. So this is what you write. Your GCF is 12. And is this relatively prime or not relatively prime?
Not relatively.
It is not relatively prime. Why not?
Because numbers can go into it, which is 6 times 2.
Because there are numbers that go into that other than a 1. Tonight is just 8 problems, and it's going to look very similar to what we did right there. Okay, that's everything you need to know about GCF, or greatest common factor.